So yeah, let's do a little bit of Sinatra review and talk about how we're going to use it in projects. Cool. Um, I posted the link to that phase 3 React Sinatra React project that's linked off of the project guidelines. I think we'll be taking a look at that. And working off of there because that's the easiest way. So I'm just going to go ahead and share my screen and we'll see what that looks like. Here, cool. That, cool, awesome. So here is, where is it? Here is the project. I'm going to just pull it down so we can look at it in code instead of on GitHub. That, yeah. Is that the actual project or is that the template? Yeah, cool. So this is the repo that we're looking at to set everything up. I'm going to go ahead and instead of forking it, because I probably already have a copy, I'm just going to, where am I? Cool. I'm going to git clone it. I'm going to go into it. And I'm going to blow away the Git stuff. Git, and we don't need that. Lucky we don't need that. Cool. I'm going to leave the git ignore there because that's important. So now here's all the stuff. So now I can do my own git repo. I have that alias to git init, git add, git commit. So now we have an own repo. And if I wanted to push it up, now it's a fresh repo and I can just push it up to my repo by creating a new one and copying the little adding a remote and pushing thing there. So let's go ahead and look at this in code, shall we? We don't need terminal anymore. Cool. So spoiler alert, this is literally the only time you'll ever be using Sinatra ever, I think. So this is good for like a sort of theoretical and structural understanding of the stuff, but if you don't remember or know Sinatra at the end of this part, you're going to be fine. Sinatra is kind of, oh, I mean, I'm not going to say it's bad because it's not bad. It's great. But it is very simple. That's what it is. It's simple. So basically what it gives you is a web server, which it uses rack for, or rack, yeah, rack, and it uses rack up to control that. So rack is the actual web server. That's the things that either serves up files if you put them in a public directory here, or it'll run code and then listen to requests and send stuff up according to that code. So rack is the web server that Sinatra uses to manage all that stuff. And the way Sinatra does that is by basically mostly provides the routing, and then we're going to bolt active record on top of that to do the database stuff. When we get to Rails in a week and change, Rails takes care of a lot of the stuff that Sinatra does, plus a bunch of other sort of scaffolding stuff. It makes it like active record writes a lot of code for you, so to do things that you would normally just be writing boilerplate code for, but we'll get to that when we get to it. For now, we're going to write that code. So I take a look through what's in this project so we can talk about everything here. First up, I think, yeah. So in the rake file, if you're curious, we can do rake server to start up the server. This is the task that does it, and make sure that there's no pending migrations. And this is the port it's going to run on. Then it's going to run rackup. And rack up is the thing that starts up the server and does the auto reloading when you change stuff and all that. Rack is the actual server. We can see that those are all in here. We got rack doors, rack contrib. So there's kind of like a pile of things here, right? We have Ruby, which is using Rack to make a basic web server, which is using Sinatra to do routing and stuff, and eventually put Rails on top of that. And that has database stuff bolted in with the active record. Let's see, anything else important? Not really. This is just setting up. Oh yeah, I mean, this is important. This is what makes everything go, our application controller. So we're going to be writing controllers here to handle our things, handle our routes. So application controller is the base controller that Sinatra is going to inherit from. Sorry, the other way around. Application controller is going to be the controller that inherits from Sinatra that we're going to add all our routes and stuff to. So Sinatra is kind of like the active record of web servers. It does a lot of that work for you. So you don't have to write all of your network listening and handling and sending stuff that way. We don't have anything really written here except for an empty application controller. So here's where we're going to be doing most of our work. It's not database work. This is going to be where we are writing routes. So we will be writing these get, post, delete, put, patch, all those there. And they're all going to live in here for now. We can break them into separate files later if we want to. Right now, just keep them all in one place. And right now, there's a default route. That route is the root route. I pronounce route like route instead of root. So I can say root route instead of root. But it has one route set up, and that's the root route. So if we start up the server, let's go ahead. We need to do a bundle install first, I think. Bundle. I should install all the good stuff that we need. Boom, great. So now we should be ready to go. We don't have a database or anything set up, or we don't have anything in our database yet. Database, all stuff can live there. So let's just start the server and see what it does. So in our rake file, we can see again that we do rake server to start that up. Boop. So rake server. If everything works, that should just start up a server. Great. Server is launched. Does it say what port? No, I don't think it does. Let's see. Oh, there it is, 9292. Cool. So just like before, when you're running a JSON server runs on a certain port and does all the JSON stuff. We're going to be running on a certain port and do all of our backend stuff. So it's running on 9292. Let's go ahead and look at what that looks like. And since there's a root route already set up, this should send us back this JSON object, which just has the key message and the string, good luck with your project. Let's see if it works. It does, great. So we've successfully built a web server, hooray. Now we just need to figure out what to do with it. So let me go ahead and write a couple test routes, I guess. So we see how get routes work. We can do, get dogs. That might do an index of the dogs. So we can do that, and we can nest those assets. Yeah. We return videos. When we do a get, we can also do parameters. So, and we put those in the URL. So I'm going to say, get, we'll say root test, and I'm going to use this is just a number. So this is telling us we're gonna, anytime it matches a route that is /test/something, let's just return your thing, your thing, params. It's in params. Params number. Yeah, so, and do 2JSON. So anything that you put in that route with the colon there, that is a parameter you're passing in, and you should be able to grab that out of the params hash. Let's see if that's true. So make sure this still works. That does. Let's just go say that works. Woof, there we go. And so now we'll do that test route and just give it a number, and that should return the number. It did, great. And we're not explicitly checking for a number, so that could literally be anything. But that's how you get params. So that's when you would do like get profile ID, or login user ID, or show this product or whatever. So that's basically get. You can get, you can, that's where you're going to be writing your index routes, your show routes, all that stuff. Other routes are basically the same. They're just, post the thing, do post, dogs, do create a new dog. You can also use parameters in here. So photos. Probably don't want to put an ID in that. If we did a patch, then we probably want to do something like that. So this would take in some data, and we would update the photo with whatever data is there. How do we send data for patches or posts, for puts or deletes? There's another parameter called body, I think it is. So if we do, let's just do a post. We're not actually going to do anything yet. Post photos, and we're just going to see what we get. I'm going to respond with and body should get you the stuff to JSON. So I'll open up Insomnia or whatever, and we'll do that. Just to sort of refresh on HTTP. HTTP is a text-based protocol, opens up connections, sends a big string, someone listens to it and does stuff with it. Most web servers that have any level of complexity will break it up. Every HTTP request has a header that says the URL and the method and whatever data up there, has a head, and it has a body, which contains a bunch of stuff, usually only used for post, patch, put, delete. Some things may throw errors if you try to get the body off of the Git. So that body gets parsed out and thrown into the body param, and we'll do something with it. So let's go ahead and open up Insomnia. If you don't use Insomnia, Insomnia is basically like Postman, only a little bit easier, I think. Maybe not as fully featured, but for basic stuff, definitely works great. So I'm going to send something to localhost 9292. Which commands did you want to share in 404? That was early on. The git commands for doing the git stuff. Was that what you're asking for? Yeah, that was just RMing the directory, so just deleting that directory. I can go back to it if you want. I'm going to post to localhost that photos, was it? Yeah. I'm going to post to this URL. And I'm going to send a body of thing one. It needs to be in quotes because it's JSON. Cool. So I'm going to send this, and cool, your data is null. Okay, why is our data null? So we sent along. Did we send it as JSON? JSON query. Don't want any bearer token. Application JSON. It is. Don't want any off. Nope. Send. No. Okay, cool. Sweet. So let's debug this a little bit. We have, I'm gonna get rid of this here for now. When we run the server, we have our log. So this tells us the requests that are happening, all that. So we can see up here, we got our get for dogs, our get for tests, our post for photos, and all that. So and this is where our puts are going to go. This is the standard output for the web server. So I'm gonna say puts. We did it. I'm gonna put params body, and since it's returning null, I'm assuming that we're gonna log null out there when we do that request. So let's see what that looks like. We did it, and then nothing. Okay, param body. Why would that not be working? Let's look at params. We can just look at all the things. Post. Great. Oops. Go send again. And so here's our params. Oh, we don't have it's not pulling the body out. Right. Sinatra does. Sometimes you have to do this explicitly, but Sinatra you don't. Sinatra will look at the body since we are sending it as JSON. We're sending it as application JSON. It will see that application JSON in the header and say, I bet the body is JSON. So it's going to parse out that JSON and throw it into params for us. So your data, I'm just going to do thing one. And that should get us this number back, your data. There we go. Okay. So when you send JSON, it will automatically break the body out and put those keys in params. What happens if you don't have keys? What if you just send a number? I don't know. Let's find out. I'm just going to send this is a string. Still valid JSON, I believe. Nope, not valid JSON. Has to be in an object. Okay, great. Yeah, so it's always going to take an object. It's always going to put those keys in params for you. So like when you fill out a form with username, login, whatever, that will you'll send that as JSON, username, login, email, etc. And those params will be put into that into params, and then you can use them. So if we are doing a post or a patch or a put, that's where you use that. Delete, you can do, you probably don't want to put it on the URL because that's a dangerous URL to do. But you would pass the parameters like, I'm going to delete, photos. And I would put photos ID here. And so I would delete that there. Cool. So that's the Sinatra basic part before we plug in Active Record. anything that's confusing up to here?
I guess this is more just like a project specific question, but like as we're doing this project, how many like of these routes would you expect us to have in this file? Would you expect it to be like massive or
Not too massive, right? So say you're doing a to-do app, right? So let's see what we have here. We would have we're not going to do login because we're not doing it off yet. So I'd have a route for get to-dos to do that will get us dogs instead. So this will get us the do items. If we want to get a specific one, that will give us the data for that one. Yeah, so then if we want to create one, we do a post. And that would take the body. If we want to do a patch, if we want to update the name. And notice we're never going to be passing an ID when we create one. That's the database's job. So patch will update one, delete the ID and body. So for, if you had just a to-do list with only to-dos, 5, right? You're probably going to have at least 3 models. So probably 15-ish, 20 if you like have a bunch of things that you do with those things. Depends on the project. So, but between a dozen and 20, give or take, depending on what you do. It's like how long is a piece of string? It's you put as many routes in as you need for your application. Does that help a little bit? Sweet. Other questions about just straight up Sinatra routes? Cool. And you could write a full on application just like this. As long as you didn't restart the server, you could keep data sitting on your keep it in your at variables in your model. Server restarts, it goes away. But so we would hook in our active record stuff here, and exactly the same thing. We would create our models with migrations. However we need there, we would we would create our database tables with our migrations. We would make a active record model for each of those things, inheriting from active record. And the controllers are, so you could put all the controllers in application controller. You can also break them out into individual controllers for each one. I believe you'd have to do some loading in here. And I don't remember how Sinatra does it. That's something I would have to look up. But just like you have separate controllers for each of your models there, you would have the same thing here. Let's see, what do we have here? Environment, maybe that will do it. Fire all app. Oh yeah, so don't have to do anything. So then we can just have, if we have our to-do DB here, we'd create a to-do model, and in controllers we'd create a to-dos to-do controller under and so in here we would probably actually inherit from the application controller. So we would say class inherits from this. Nope. To do controller. and we inherit from application controller. And so this gets all the good stuff from here in case we have any, if we have any like helper methods, we might want to put them in there, and then we can just call them on our classes. But yeah, this inherits everything from Sinatra and then back down here. So here's where you could do all your get whatever and put all your methods in there. And when we are using active record, then we're going to be using active record to get our data. So we have get to do's, do. Here's where we would say, cool, we have to do's. Oof, to do's, all to JSON. And this would return all of the to do's. If we wanted to get one, we'd do a get by ID. No, this is right. Yeah. Is it in quotes? I don't remember. Yeah, it's a string. Space on that. Do's. We got to get a specific one. And go do to do's. To do. To do find by ID. ID. Send that back. And all the active record methods that you just showed me that you can use. Like creating and destroying and all that. And that's you can do basic CRUD pretty easily. And in fact, once you get it once, you can use that as a template. Or if you wanted to be real spicy, you could make a class that looked at the name of the class and then built all those out. And then you would be on your way to building Rails, that's what that does. Yeah, so hooking in active record, again, all of this, just because it's using Sinatra is literally just a Ruby gem that we're importing here. All it does is provide some of the basic functionality for the web server. This is still just straight up Ruby. We're creating a class, it's inheriting from this other class. We're adding some, these get post patch are methods that are provided by Sinatra, so we can just use those in ours. But all of this is just straight up Ruby code. And just because it uses active record, it's not special. It just does the thing that we ask it to. And like we saw, you can use active record without Sinatra. You can use Sinatra without active record. You can use them together. You can use them with something else. It's all bits and pieces you can plug in and play with. That's the big overview of Sinatra. There's not a whole lot more to it than that. You can get away with, I mean, if you for some reason decide you don't want to learn Rails, and I'm sure there are good reasons, you could totally get away with just building a full-on web application just with Sinatra. People did it. Rails is built on a Sinatra, so people still do it, I guess. Or is it just built on a rack now? I forget. It was built on Sinatra for a while. It's not anymore. But yeah, that's pretty much it. And then for the front end, since we just have a URL here, we would build our React front end just the way we have in the past. When we do our fetches, we're going to be fetching from the URLs that we set up. So we're going to have our React application started on one hand, we're going to have our backend started on the other. And when the React application makes requests to that URL, that server will respond with the stuff. Pretty easy. Not easy, it's really complicated. But yeah, that's the basics. What questions do you have for me? Or what would you like to go more in depth in?
So the methods like you have in that second get right there, like that method that we would have been building in the models,
yeah,
like we did in the code challenge stuff. Now we'd be building methods like that in the controllers, or would we still be building them in models?
Yeah, that's a great question. So answer is you could do it either way. the controller is the thing that Sinatra is going to listen to. So we can use active record here and not really worry too much about what's in the models. Or we could, in the models, we could make a function, pretend this is the model file. We would have a function that's, to do index. And then in here, we would just return probably just return the thing. So we would get the list of stuff. And then in our controller, we would do our get to do's ID. And this would, or just get to do's and do. And in here, we would do, well, this would have to be on that. We would say to do index. Just call it index, I guess. Which to JSON. So for this example, doesn't make too much sense to do that, but we can, pass this in, and after we write the method, we can do to do. I guess we do get ID. But if the things we wanted to do were more complicated, like if we wanted to, get this model and get some of its stuff and then take things out of its stuff and put it together and, combine things in some way, we could still do those here. They might make more sense to do in the models. I think I tend to default doing stuff in the controllers in Sinatra when I do it, which is very rarely. There's no reason not to do it in the controller, in the model. I think you'll find yourself doing a lot of extra typing for that. Rails, I think, keeps everything in the controller pretty much. So that's probably good to do there. And then, yeah, you would write model methods. So you would do like I would make a restaurant self highest rated method. So I could use that in my controller. I would do a blockbusters on movie that returns all the movies that this thing has, or build a user to-dos thing that did a find on the users, or a TV show thing returns all the ratings for a TV show that we can then send up to the controller. But it's really a matter of taste. I think the way that I code is generally make it work first and then refactor, unless it's something I do over and over again and I know I have to do. So I would generally default to doing stuff in the controller. And if I notice that it's getting too complicated, or if I'm repeating myself, then I would look at pulling stuff out and putting it into the models. But if it works, it works. So whatever makes more sense to you is the right answer.
Okay, another question. So those are all, how would you do like instance methods in the controller, or how would you act as set? Because those seem to be all class methods, right?
So these are, oh yeah. So let me get rid of this stuff. You would just get so we have I don't know which one. What do we want to do? What's an example of an instance method? If I have let's do the restaurants, right? We have restaurants and reviews, and I want to get all the restaurants, I want to return all the reviews given a restaurant's ID, right? So the route would look like reviews ID, something like that, or ID reviews, restaurants, yeah. So this is, I would be going to the URL, put restaurant 1 reviews. And so we want to get all the reviews for that one restaurant and then return that as JSON. So again, we would just do regular old Ruby stuff. So we would say Yep, restaurants equals restaurants, capital R. Find by grams ID. And then we would just return restaurant reviews. And of course, you could stack this up here as well. So this is a instance method there, just like that. But yeah, same deal. Does that answer what you're looking for?
Yeah, that definitely helps.
Awesome. Cool. Other questions? Sweet. Well, hopefully this will be enough to get you going. Did I skip anything? I don't think so. Yeah, you should be able to do your project with just this information. I'm sure you'll do more things that require more. But yeah, oh, did you have something?
Yeah, I just want to make sure I'm not like completely missing, the boat here. You have a JSON or a server, and then Ruby and Sinatra is basically acting as sort of the middleman between the UI and that server. So when we make,
what server are you talking about here?
I guess that's where I'm confused. The
Yeah,
JSON server.
Yeah. So basically, what we're doing is we are building something to replace what we would have used JSON server before.
Okay.
It is talking to a server though, and that server is the database. So
the that we've been using this whole time.
Yeah. So our SQLite database that we do our migrations and seeds and stuff in, that is, I mean, whatever kind of database you use, those are literally just files on a computer, and the database program is a server. SQLite connects on 5432 or something like that. But basically, when you do a find or something, say we do an all, active record is going to look at the class we're calling that on. It's going to find the right model and find the right table. It's going to put together an SQL query that says, select all from to-dos, and then it's going to send that SQL query. It's going to make a network connection just like we are when we do a HTTP request, only it's a database request. It's going to connect to the database server and send it that SQL, and the database server is going to do its thing and send back some data. And then we're going to grab that on the Ruby side and do stuff with it and probably send it back up. So you're basically right when you started off, but the database, the server we were talking about is the database.
That's what we're making. We're basically using Ruby to make that server, and that however we do that, either with like we could do seed, we could do however we make the database, and then we're pulling from it and doing stuff with that through Rails, or sorry, through Ruby. And then when I'm looking at like the JavaScript side of it, when we make the fetch request, we're making it to this localhost 9292 or whatever server it is on our computer. And when we make like a use state fetch request, we're actually going to these routes. And this is like our API like URL. We're actually building that URL out. So localhost 9292/to-dos would be that endpoint for the database. Very cool. All right. Yeah. That totally makes sense.
We are literally building an API here.
Awesome. That totally makes sense. Thank you.
And the reason that we do it separately, because old style, we would build our HTML pages on the server as well and send those up as a response to a GET/request or whatever. The nice thing about having your backend server and your front end separate is that we can work on our local server here, have our front end connect to this, and then when we want to publish it or host it, we send that back end to another server, and we just tell our front end, hey, point to that server over there instead. Or if we have multiple servers on our back end, if we have a testing, staging, whatever server, we can have the same front end point to different servers. Conversely, if we have a server that's hosted somewhere, we can write our front end in React, or we can make a mobile front end, or make an Alexa skill that talks to the back end. So we can have multiple different kinds of things consuming that API that we built, and really nice separation of functionality and display and interaction.
Awesome.
Yeah.
Very cool.
Sometimes you will see what they call monolithic applications, where there's one big code base and that serves up both the front and the back end. That's all right. That is, some people prefer it. Some people have some decent arguments for doing it that way. I find that really brittle, and I think, general best practice leans more heavily towards separating front and back end. But you'll definitely come across people who are like, monolithic's the only way forever, amen.
So I just logistically, and I don't want to hold everybody up here. Like we could I could even just go into a React app that I've already built out, and if things match up and I'm just change the endpoints to whatever I set it up to be, that data coming back could be, different images or different whatever. But I mean, it's that simple.
Yeah.
You just set up one side, then you set up the back end, and then you just make the fetch request to yourself almost.
Yep. Yeah.
Cool. All right. Yeah. That makes me feel a lot better.
Yeah. And another sort of advantage to this method is you could, stub out a backend using JSON server. Like, I'm just gonna have some simple test data, it has the gets and puts and patches and deletes. I'm just gonna make that with the JSON server, real simple, real fast. I'm gonna build my front end that talks to that, and then I can go ahead and build a more fully featured backend API to replace that, as long as we have the same interface, and we can add stuff to it or enhance it or whatever. Like, you wouldn't want to do a JSON server on a production machine. You would want to use a database. Yeah, so that lets you kind of like progressively, or even fake it entirely. If you have a stubbed out backend that, like, instead of this, you hard code a hash of sample to-dos and have it return that, just so you can build out that display on your front end. The backend doesn't need to do anything real, as long as the API is sending stuff that you can test against. So it really has a nice progressive, it lets you build in steps. And the same thing with the front end. You could, start building out your back end, and your front end, you could just use Insomnia. You don't need to build a React app. You could just test your API with Insomnia. Or you could have one person working on the back end and one person working on the front end, as long as you're both programming to this API that you've agreed to. How you do it, that they could be using React or Angular or Vue or whatever. On the back end, you could be using Rails, C, .NET, Perl, whatever you like, FileMaker Pro, all sorts of things. So as long as you have, that's why like APRs are such a strong thing that we do, because it really allows that sharp separation of what we do on the front end, what we do on the back end.
Awesome. Thank you. I mean, it sounds like I can, build out a skeleton of a app and get that running, and then build out a skeleton just get like a endpoint working, and then, just connect them together and have it show up in the browser, and then off to the races. Thank you, Mark. Awesome.
Yeah. So there's talking more about development. There are different ways you can approach stuff, right? You can write out your API and then just build out your back end, or just build out your front end and then do the other way around. you could, the way I prefer to do it is like thin vertical slices, meaning that I'm going to pick one thing to do and kind of make sure it works front to back. So I would have, I would build out like an index route, or even just my standard route is just a git slash booyah, and that returns and that'll be the first app in first route in pretty much any app that I write for some reason. Got into that happen a long time ago, and clearly a long time ago. But yes, but just having one route on your API that does something super basic lets you decide what you're doing on the front end, decide what you're doing on the back end, make sure your database works, make sure the web server is handling routes correctly, make sure your React or whatever you're using on the front is able to hit a route. And so when you get that one little slice done, then you're just like ready to roll, and you can from there say, I'm going to work just on getting the listed to-dos working, and then get that working end to end. And I'm going to work on getting an individual to-do to show, work on that end to end. And that lets you split up work on a team really easily too. Say, one person's going to work on the user profile stuff, one person's going to work on the item cards, one person's going to work on the shopping cart, and they can do these thin vertical slices in parallel. In feature branches, of course, they get merged back into your main branch. Yeah, so that's, but if you were to just be like, we're just building out the back end today and tomorrow, that's totally fine too. Because you can just test it with a click or Insomnia or Postman or whatever. So again, whatever way works for you / your team.
Awesome. Thank you.
Sinatra Ruby is the server. Yeah, it is a server. Yeah, and that is talking to another server, which is the database. There's just servers all the way down. The database talks to the operating system. Yeah, it's just levels on levels on levels. Cool. Other questions?
Are there any like common snags that people hit like in working together on a project where you have like like where's like the biggest issues that we can try to avoid?
Yeah, the main issue is merge conflicts. Well, the main technical issue is merge conflicts. So if you have, again, like if you're working on one big file, if you decide to do all your stuff in application controller and multiple people were working on that file, it's possible that you could kind of overstep each other. But using feature branches really helps that. Anytime you're going to work on something, make a branch for it, get it working, merge it back into main. So that way multiple people can work on things and not get in each other's way. When you merge it back into main, merge main into yourself first to make sure everything's good. But if there's a merge conflict, then you talk to your coding partner and say, hey, is it okay if I move this around or that? And they say, yeah, cool. Duplication of work can be a snag sometimes, but most of these issues are just solved with good communication, whether it's sitting down and chatting with someone or having a intricate issue tracking system. Yeah, like technically, I think those are the main ones. Yeah. Cool. Other questions?
This might be a dumb question, but this is all in one environment that we're building this in. So pop open one window in VS Code, and then you have like I'm looking here, like this example has like a whole client directory that everything's in for like JavaScript and React, and then there's another one that has the server and then everything in there. And then like inside the main directory is everything else, like the readmes and
so this what am I saying? This one that we are looking at right here is just the server. So if this would be in a repo called my project / backend or dash backend, then I would in terminal I'd do a repo. This is gonna be my sweet project. Then I would do a create npx create React app sweet project front end, and that would make that front end. I would put each of those in their own repo, so you would have two GitHub repos, one with the front end, one with the back end, and that ensures that like you have no sort of cross contamination. Again, you'll see it done different ways. This is the way I prefer to do it. So yeah, and then you would have two VS Code instances open to work on the front and back end. Or if you had both of those repos checked out, you could look at it from the parent directory, but that'll work. Did that answer what you're asking?
Yeah. So it is actually two instances of VS Code, one for the back end, one for the front end, and they talk to each other through fetching to the server or whatever. Yeah. Awesome. Yeah, that's super cool. Thank you.
Cool.
Okay, so just to clarify, you run like when you have your back end set up and you have some data that you've generated, you run your server, then in your React app VS Code, you put in the like link that or like the where you're hosting it on that server once it's running into your okay. Yeah. So really like this will only like work like when you're running your server on your computer.
Exactly.
Like
yes.
Yeah. Okay.
Yeah.
Okay.
Yeah. So in this in this React app, I would do a fetch to localhost 9292/todos, and that would make a request to the server that's running.
In the browser, you would actually be running the React app,
right?
And then those would be your endpoints or whatever URL. You organize it however you want.
Yeah.
Thank you so much. Okay.
Yeah.
Cool.
Yeah, and this can definitely be confusing when you're not used to it. So let me go in here. npm start. And I'll do why are you over there? Cool. So I was running on 3000. I can open that up, and then that'll be in a separate VS Code. And so there's my front end, there's my back end. And now I can go into my app.js and get rid of all this. Say do a how do I do JavaScript again? Use effect.
I missed it so much.
No.
It's so nice to see like JavaScript and React again.
So I'll use effects, and I'll do a fetch to have this in a variable. Do a fetch to localhost 9292 / booyah. Then geez. Then response JSON, and then we'll do a state const message. New state message. And then this will be I think that's how React works. No, that's a lie. Cool. So I have, where are we in here? JSON. Oh, didn't set. Then set message with JSON. And what did I call it over here? Oh, where'd my booyah root go? Put it back. Did I put in the other one? I bet I did. Go back. here. So I'll put this one on my application controller. Oh, these are all empty, right? Let me move the directory. Let me code that up again. Backend. That's all working in the right directory. Cool. Now, there we go. Move that to my application controller. Boom. So I should be able to, once I start this, go to, I'll say message. Should be able to go to localhost 9292. Here we are. Great, there's my message there. JSON is not defined. Tell me more. JSON. I assure you that there is only at once.
You have to do res.json. Is that
Res.
what you're missing there?
Oh, yep, that's what I'm missing there. Cool, getting closer. Pull all this out for just a second. Oh, there we go. That's finished. Great. Okay, that works. So just tiny font up top, message, nothing. What did we do wrong? Oh, did we not? No, we did, right? Yeah, we started it. Look, oh, all the template stuff. Get the logo. Yeah, it's fine. Okay, let's look at our network and see. Whoa, all sorts of errors. Destroy it. Use effect is not. Oh, yes. Use effect. Then. Oh, it's not working. Cool. See if that works. Nope. Local hook. Maybe I should put a HTTP on that. What do we think about that? Hey, there we go. Cool. So full stack application. Here's our front end. It is loading up, making a call to the URL our backend is working on. It's going to get that message JSON back. It's hitting this route and it's just sending that JSON back. So there we go. And we can see in our network tab that it is doing exactly that. Clear it out. Reload. So here is our fetch. It's making that GET request, getting that data back. Wow. Cool. And then just from there, just draw the rest of the owl. That's all I need to do. Awesome. So yeah, answer to your question. You just do that.
That was really, really helpful. I mean, you kind of just put it all together there. So
Yeah,
thank you.
Yeah, you bet. Any other questions, especially about all this?
This may say kind of silly, but we are generating like our own data, right? Like in our, like a seed file. Okay.
Yeah.
Okay.
Yeah, you're definitely grab stuff in a seed file here. Where you get that data is up to you. You could definitely hit another API or scrape a web page or grab a text file and build that out. Yeah, but you will be using the data in your database. How it gets there is not my business. Yeah, Faker, super good. Cool. That's about an hour. Final questions? Feeling good? Yeah. Let me stop recording and thanks for hanging out. All blah, 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 blah.